Good morning. Happy snow day. We're going to do a quick warm-up question. This is actually one of the questions from last Friday's activity. So I'm going to read through it and demonstrate how to solve it, but I want you to pay attention to the process. And there's going to be a do now question about the steps that we're taking to solve a problem like this. It says a shuttle leaving Earth's atmosphere travels 15 miles every 2 seconds. When entering the Earth's atmosphere, the shuttle travels 2 3/8 miles per 1/2 second. Find the difference in the distances traveled after 15 seconds when leaving and entering the atmosphere. So the first thing I notice is that I'm going to be comparing two different ratios. So I want to set up a ratio table, one for leaving the Earth's atmosphere and one for entering the Earth's atmosphere. And my goal is to figure out the distance traveled after 15 seconds so I can make a comparison, so I can find the difference between the two. All right, so that's why you see 15 at the end here. So the first thing in my table, I need to write the original ratio that's given to me for each set. So I have 15 miles every 2 seconds. It's the first ratio I'm going to put in my table. Then I have 2 3/8 miles per 1/2 second. And that's my original ratio for the second set. Now the reason you see the space in between, this column in between before I get to the ratio that has 15 seconds at the bottom, is because I want to find the unit rate for each one of them. All right, that is the miles per second that it's traveling. So the way we've been practicing miles per second or finding the unit rate is we're doing the top number divided by the bottom number. So we're looking at this as 15 divided by 2, right? Because 2 divided by 2 is 1. So I do the same thing to the top. 15 divided by 2 is 7.5. I'm going to use decimals here instead of fractions. I just think it's a little bit easier, right? For this one, I already have a fraction, but the nice thing is I know that a half times 2, right? 1/2 times 2 is a whole. So I'm going to do the same thing to 2 3/8. I have 2 3/8 times 2. Now I'm going to use a little mental math here because I don't really want to take the time to set this whole thing up. Improper fraction, two fractions, multiply top, multiply bottom. You can do that. But if I'm looking at this, I want to do 2 times 2 and 3/8 times 2 and put them together. 2 times 2 is 4. 3/8 times 2 is 6/8. So now I'm putting together 4 and 6/8. Or if I want to turn that into a decimal, 6 divided by 8 is 0.75. So 4.75. All right, I like decimal format because it helps me with my calculator. Now the best part about having a unit rate in the middle is it's really easy to turn your unit rate into the ratio that we're looking for. I recognize here that I need it to be not 1 second, but 15 seconds. So it's just times 15, right? 1 times 15. So I do the same thing to the top, 7.5 times 15. Same down here, 1 times 15. So I do the same thing to the top, 4.75 times 15. So once I've finished multiplying that out, you can see here that leaving the Earth's atmosphere, all right, the shuttle travels 112.5 miles in 15 seconds. Entering the Earth's atmosphere is 71.25 miles in 15 seconds. Clearly, it's moving much faster leaving than it is entering, which brings me to the actual question. The question is find the difference in the distances in 15 seconds between leaving and entering, right? And this word difference implies I need to compare these two with subtraction. So let's set that up. 112 minus 71. And of course, the decimals included. All right. Your final answer should come out to 41 and 25 hundredths miles.